previous information, but this is like very basic. This is from all of you should have studied at school, maybe in Arabic, but this is just basic, just to set the tone for the course, okay? And it's going to be slightly different. It's just a review of what you should know from school. Okay, so we're going to talk about the structure of water, why water is polar, what is hydrogen bonds, what is the importance of hydrogen bonds in making a substance dissolving in water or no, and we're going to talk about molecules that has two parts, a part that like water and a part that hate water. And sorry, I missed the last word, but why pH is important for biochemistry. First of all, what is biochemistry about? Before I start with this slide, what is biochemistry about? When you say biochemistry, what does it mean? Yes? Okay, so it is in a simple word, it is the chemistry of life. Okay, so we are studying the chemical properties and the chemical reactions of the molecules in our body. Okay, so we want to know the chemical reactions that take place in our body. So how we store sugar, how we store fat, how we break fat, how we break sugar, where do we store sugar, do we store protein, yes or no, and what happened to the amino acids in our body. So this is what we will be learning in biochemistry. So it is the chemistry of life, chemistry of the body. So in the biochemistry, most of the lectures will be either structural, so you're going to study the molecules, the large molecules that make up life, and these are the DNA or the nucleic acids. Then what are the 4 macromolecules that make up our body?
Proteins, lipids.
Who can list them, the 4? Yes? Amino acids. So amino acids make up protein. So protein, lipids, carbohydrates, and nucleic acids. So these are the 4 macromolecules, the large molecules that make up our body, and these are the ones that we will study. We study their structure and we study how they react in our body. Okay? And all these molecules will have a specific shape in our body because of water. Our body is made up mostly of water, and these molecules will be facing the water in our body, right? So these molecules that we are going to study will have a certain shape because of the presence of water. So that's why we need to understand the structure of water and how water, influence the shape of other molecules. Also, the reactions that you will study in biochemistry will occur, most of them will occur in water. Okay? So this is the medium. Water is the medium for the major or most of the biochemical reaction. And water itself participates in this reaction. That's why we need to understand what are the properties of water. Who can explain to me the shape of a water molecule? Yes?
It's kind of bent.
Okay. So what is water made from? Yes, so we have 1 oxygen and 2 hydrogen. Okay? Can you tell me about the difference between why we have this arrow and this plus and minus? Who can explain to me? Yes?
The oxygen is more electronegative.
Excellent. What does electronegative mean? Yes?
The tendency of an atom to attract a ferroelectron.
Excellent. So oxygen is better at attracting electrons. So the electrons will be spending more time near the oxygen. Although we have a covalent bond where there should be equal sharing of electrons, this is not the case in the water molecule because oxygen is more electronegative, right? So the electrons will have a tendency to be nearer to the oxygen, to spend more time nearer to the oxygen, which will give the oxygen a partial negative charge. Okay, so this delta is the partial negative charge. At the same time, because the electron is spending more time here, so the hydrogen will partial positive charge. Because we have partial positive and partial negative, this will give a molecule
Polar.
a polarity.
Polarity.
Okay, because we have plus to minus, so we have polarity. Okay, this polarity is needed for the formation of hydrogen bonds. So what are hydrogen bonds? Yes?
Hydrogen attracts to thing or O or F.
Okay, so what type of bonds they are? Yes?
Carbon, I think.
Sorry?
Carbon.
Carbon. So hydrogen bonds, like your friend said, they involve hydrogen and they are weak bonds. Okay, they are much weaker than covalent bonds. So they are 1/10 or 1/20th the strength of a covalent bond. Okay? Weak bonds, yes, but if you have so many weak bonds, they will make an effect. That's why they are important in water, because within water, the water molecule themselves, because of this polarity, they are capable of forming hydrogen bonds. So we have hydrogen bonds between the oxygen and the hydrogen between the molecules, not within the molecule. Okay, within the molecule we have covalent bond. Okay, between the different molecules we have the hydrogen bonds. Okay, so this hydrogen bonds make the water, all together, put the water all together, but also it's important to make things dissolve in water. Okay, so this is the hydrogen bond, we represent it as dash, and this is the covalent bond. So this is inside the water molecule, and this is between the different water molecules. Clear? Okay, so why we need to talk about polarity and hydrogen bonds? Because it will dictate whether something will dissolve in water or no. One way to dissolve in water is to have ionic bond or ionic interaction, and this is the case of salt. What is salt? Sodium chloride, NaCl. If you put NaCl in water, what will happen?
Dissolve.
It will break into Na plus and Cl minus. So the Na plus will form ionic bond or ionic interaction with the water, and same for the Cl minus. So this is easy. If you have something that form ions, it will quickly and easily dissolve in water. But some things, they don't form ions, and yet they can dissolve in water. And these are the molecules that can form hydrogen bonds. So one way to dissolve with water is to have ionic bond. The other way is to form hydrogen bond. And this is important for substances that are like urea. So here in blue, you have urea. Urea is made of C, N, and H. We'll study urea later in the course. Okay, so it's not capable of forming ions, yet it can dissolve in water. Why? Because it has NH. So the NH will interact with the oxygen, and it has the O here that can interact with the H. So we have hydrogen bonds formation, and this makes urea a substance that dissolves in water, or what we call hydrophilic. What does hydrophilic mean?
Loves water, dissolving water.
Okay, hydro is water, philic
Love.
to love. Okay,
Yeah.
so it loves water, therefore it's going to dissolve in water. Unlike substances that hate water. So here we are talking about the hydrogen bond. So to have a hydrogen bond, we have to have an acceptor of electrons, something that can pull electrons toward its side. Sorry. So it can be an oxygen with a partial negative charge. So these are the acceptors. And it can be a nitrogen with a partial negative charge. But there is always an H. That's why we call it hydrogen bonds. So the H is usually the donor, the one with the partial positive. So it's H that is in NH or that is in OH most of the time, but also we have SH. Okay, don't worry if you don't get the idea now. We'll come back to polarity later when we study the amino acids. Okay, so we said some molecules love water, but some molecules hate water. So what do we call molecules that hate water?
Hydrophobic.
Okay, what does the hate water mean they don't visit water?
No, they don't
They
dissolve
cannot
in.
dissolve in water. So what type of molecule, what is special about this molecule? What can you see? It's mainly made of
Triglyceride. Glycerol.
C and H. C
Yeah.
and H. What are C and H? Hydrocarbon. So this is a hydrocarbon. Because in hydrocarbon molecules, there is equal sharing of electrons. There will not be any polarity. And no polarity means no hydrogen bonds. No hydrogen bonds mean it cannot dissolve in water. And the larger the hydrocarbon, the worse is the ability to dissolve in water. Okay? So the longer the chain, the more the hydrophobic. What is this molecule? It's a lipid. We will come back to it later when we study lipid. Okay, some lipids, they have two parts. You know, some people, they are good and bad to you. So same here, we have amphipathic molecule. You know, they have two sides.
Yeah.
A side that likes water, and this is here in the phosphate, and the side that hates water, and this is the hydrocarbon tail. So that this makes this molecule amphipathic. What does the word amphipathic remind you of? Amphibian. Okay, that's amphoteric, but amphibian is easier word for you now. So amphibian, they live in water and on land, like the frog. Okay, this molecule has a part that hates water and a part that likes water. So this is the phospholipid, a cartoon illustration of phospholipids. So you can see one here and many of them here. So there is a head that likes water, this is the phosphate, and the tail, this is the hydrocarbon tail that hates water. So when faced with water, what will happen? So this is how molecules behave in presence of water. The part of the molecule that likes water will be facing the water, and the part that hates the water will try to hide away from water.
Yes.
And this is going to be the same for a protein who has amino acids. Some amino acids hide water, and some amino acids hate water, and some amino acids love water. So that's why you need to understand this, okay? So in a molecule where there is something that is hydrophobic, the hydrophobic part will be away, and the hydrophilic part will be toward the water. Okay, you will study this again when you study the membrane, the cell membrane, but also when we study the lipid, the fats, and how they form micelles. Okay, so the micelle formation is a way of hiding, trying to hide everything that hates water inside. Yes?
Can you go back to the previous slide?
This one?
Yeah.
Yes.
How did you know that the left side is the hydrophilic?
This one, because it has a phosphate, it has a negative charge. So the phosphate as a group, the phosphate groups, it form ionic interactions. So it's easily dissolved in water, okay? Last part, I'm not going to talk about it in detail because you are going to study it in lecture 6, I think. So Dr. Abdel Jabbar will talk to you about pH. So what is pH? What are you trying to measure in pH? Acidity. So what is acidity? Concentration of
hydrogen ions.
hydronium ion. Concentration of H+. Okay? So what is difficult in the pH concept? The pH is minus log, right?
Yeah.
So the higher the concentration of acid,
The lower
the pH, because it's a minus log. So there is inverse relationship between the pH and acidity. Okay? So this is one, difficult things about the pH. The other difficult things, because it's a log scale, what does it mean? This is a log scale. So any difference in 1 unit in pH, so let's say if you compare pH 1 and pH 2, because it's a log scale, how much is the difference in the concentration?
0.
10 times.
10 times.
Okay, so that's why our body cannot afford to have a difference by 1 in pH. Okay, actually our body pH, especially our arterial blood gases pH. Sorry, our arterial blood. I don't know where gases came from. Okay, so inside our blood, inside our arteries, the normal pH range is between 7.37 and 7.43. Very narrow. Why it's very narrow? Because, yes?
Blood is a buffer solution.
Yes, and why we have to maintain this narrow pH? Because, yes?
Enzymes work at certain pH range.
Yes, so our enzymes work at certain pH, and we have to maintain it because, you know, a small fluctuation will mean that there is a big difference in acidity, so we don't want to change this acidity. We want to maintain this narrow pH. Okay, so Dr. Abdel Jabbar will explain to you the relationship between the pH and the pKa, which is something that is the property of an acid. So every acid has a pKa, the weak acids. And this equation, the Henderson-Hasselbalch, is an important equation because it will tell you how pH is affected by the concentration of the acid or its conjugate base. So this is the titration curve that Dr. Abdel Jabbar will talk to you about in lecture 6. And this is why we need to know it, because there are many mechanisms in our body that has to do with this equation, the Henderson-Hasselbalch equation. One illustration here is in our lung. If someone for any reason has a lung obstruction, they cannot get rid of CO2, what will happen to CO2 in our body? CO2 can form a weak acid, okay? So if you have too much of this acid, according to the equation, what will happen here to the pH?
Will increase.
pH will decrease.
Yeah.
We're having too much acid, so the pH will decrease according to this equation. Too many bicarbonate, which is coming from the carbonic acid here, will drop the pH. A drop in pH will cause something in our body called acidosis. Okay, there are different reasons for acidosis. One of them is because of respiration, so respiratory acidosis. You will study later also metabolic acidosis. So acidosis is not a good thing, okay? So it can have many complications in our body, and it is controlled by this equation that you need to understand. Another example on why pH and the Henderson-Hasselbalch equation is important here has to do with the drug absorption. So here we are showing you that in order for aspirin to go from the stomach to the blood, it has to be in this form, which is the unprotonated form. Okay?
Yeah.
The drug H or the HA, it means the uncharged form. The one without a charge or the one that has a proton. So I made a mistake. I will repeat. So in order to cross from the stomach to the blood, for aspirin to work, okay, it has to be in which form? HA. HA is the one that has proton but has no charge. Okay? So because only uncharged drugs will cross the membrane, or they do it faster than the charged molecules, so that's why the pH of the stomach needs to be maintained as at a low pH. Why? According to this equation, if the pH here is lower than the pKa, which is a dominant form of the drug, this form is a dominant form. Okay? Don't worry if you don't get it now, it's normal, but Dr. Abdel Jabbar will come back and will talk to you about these two equations or these two illustrations of the equation later. Okay, this is the end of my lecture. I will give you 10 minutes break, and then we'll come back for the gene to protein lecture.